All right, let's take a look at some sequences. We're focusing on geometric sequences and look at like these first two numbers. With 2 to 6, I have two ways to get to it. I can either do, to get to 6, I can either be adding 4, I could be multiplying by 3. If the next number after that, like if I add by 4, 2 plus 4 is 6, let's do plus 4 again, we would get 10. If instead I multiplied by 3, 2 times 3 is 6, 6 times 3 is 18. We have an 18, that means we have a multiplying thing. So to go from 2 to 6, we would multiply by 3. And to go from 6 to 18, we're multiplying by 3. And 18 to 54, that's multiplying by 3. And 54 to 162, that's multiplying by 3. So that means that every time we're multiplying to get 3 to it, if you're multiplying to change the number, then it's a geometric sequence. We are going to take the time to write an equation for it and find the amount at the 10th term. So this is the type of equation. And just like before in doing exponential growth and decay problems, we actually have meaning for each one of these. AN is the amount at the nth term. A1 is the first term, amount of it. R is the common ratio. A little typo on here, so cross out that N. Okay. And N is the number of the term. So the amount of the nth term we don't know yet. And here's what's happening. I'm going to rewrite these to show a little bit about it. I'm going to do 2, 6, 18, 54, 162. Okay, so this is the first term. Here's the second term, the third term, the fourth term, the fifth term. So if that's the first term, 2 is actually the amount of the first term. 6 is the amount of the second term. 18 is the amount of the third term. 54 is the amount of the fourth term. And here we have the amount of the fifth term. We can keep going. Ultimately, we'll get the amount at the 10th term, which is what we're going to be asked in a moment. But at some point here, we're going to get one where we don't know how it is. What we know is that it's the nth term. So we would call that A to the nth term. Okay. And that's why we use AN for the amount that we're going to get to. All right. The first term, here it is, A1. We don't know yet what that is. The common ratio is that multiplier that you get to each time. Now, here's the thing. This one, it's easy to tell. But if you can't tell, what you do is you take the second one and divide it by the first one, and you get a 3. So you have to go backwards and make it a fraction, 6 over 2. Then we do it with this one, 18 over 6. So the third one divided by the second, that's also 3. 54 divided by 18 is also 3. 162 over 54 is also 3. 54 is 3. So notice that it's the same number each time that you multiply to. 2 times 3 is 6, times 3, times 3, times 3. So the common ratio is 3. The n is the number of the term. Okay, so when we want to do the 10th term, we'll be able to use that. Down here in this next one, we're actually making the equation. Okay, so told you that was the equation. And here now is what it comes to. All we have to do is fill in the two things that we need, which is the A1 and the R. Okay, so that's A1 and that's R. And we got A1 here, and we got R through all of this. So now that we have that equation, now we can put in the 10 into its place. Okay, let's come back. No, we want to know when n is 10. So look at what happens here. Okay, we say A10, and then we put a 10 in for the n there. That makes it 9. 3 to the 9th power is that, multiplied by 2. So the amount of the 10th term is 39,366. Now, let's do one of these, and this time it's going to be with some negatives in it. interesting thing. So here are what we have. Let's immediately say that this is A1 or the first term, A2, A3, and A4. So we need to write an equation. So we need to know A1, which is negative 64, and then we need the ratio. So for the ratio, we take the second term and divide by the first. Ah, it looks like that's negative 1/2. And then we do it with the third term, negative 16, and divide by 32. That's also negative 1/2. And then the fourth term divided by the third term is negative 1/2. We have negative 1/2 each time, or we can say negative 0.5, entirely your choice. Okay. So the equation is going to be AN, we're not used to doing it for the 10, is equal to the amount of the first term. Let's do A1 and then R to the N minus 1. Yep, numbers. So we know that AN is first term, negative 64. And the ratio we now know is negative 1/2 or negative 0.5 and minus 1. That's the equation because we have it set up now where if I'm given an n, I will get the amount at that nth term. But I can put any n in there, so I can't limit myself by putting an n in right now. I have to leave it n, and that makes this a general equation. So that's letter A done. For B now, the 10th term, now we'll put that in here. So AN is equal, I'm going to make that since I'm doing the 10th one. Let's make it A10, negative 64, negative 0.5, and then that's 10 minus 1, or not. So we would do negative 0.5 to the 9th power, and then multiply a 64. So the A to the 10, the 10th term is 0.125. Okay, so if we kept going, let's keep multiplying by 1/2. That's going to be 4, 2, 1, 1/2, and then 1/4, and let's see that to 1/8. And at this point, this is actually 1/8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1/8, if you change it to fraction form, is 0.125. And that's what we have here. Okay. Let's look at a couple of practice problems. This one is very similar to it. Oh, now this one's also the negatives. Let's go back and look at something here. Okay. We have a negative for the first term and a negative for the third. Every odd one will have a negative. Every even one, every even term number like 2 and 4 will have an even number. So when we get to the 10th one, following this, because it's an even number, it should be a positive answer. And indeed it is. It's a positive number. So it matches that pattern. On this one now, the second and the fourth one are all the even ones have a negative. Well, let's go ahead and make the equation for this. I guess I'll leave it this one. AN is equal to A1 R N minus 1. So A1 is equal to 4. And for R, we're going to do that thing where I take the second one and divide by the fourth. Okay. And that's negative 2. Take the 16 and divide by negative 8. 16 divided by 8 is 2, and it's negative. Negative 32 divided by 16 is also going to be a negative 2. So we know that the ratio is a negative 2. Okay. 1 equals 4, R equals negative 2. So let's put them in the formula. The amount at the nth term is 4 for A1, and then negative 2 for the R, and N minus 1, because we don't know yet how, what number to put in. In fact, this right here is the answer. we want the actual equation for it. Okay, now having done that, all we need is a time. If I'm given a certain amount of time, I'll be able to figure out the amount at that nth term, or that time amount. Put AT, I guess. This one doesn't ask for that. So let's make one. Let's just say it's the 10th year. Okay, n equals 10. Just so we have one to work with. Okay, well, actually, I don't want to go that far with this one. I have it set up with an example of 6. So we're going to go n is equal to 6. So the amount at the 6th term is equal to 4 minus 2, 6 minus 1, or 5. So we'll do, I don't want to do 5. No, I had 10 before. I think I actually meant to keep 10. So it's 10. This is 10 minus 1 for the number 9. So we have negative 2 to the 9th power, and then times 4. And that's going to be the negative 2048. So the amount, that's right, because that's 10 too. The amount at the 10th term is negative 2048. Now, the fact that it's negative is confirmed because back up here, it's the even ones, a second, a fourth. And so now at the A10th, it's going to be a negative as well. Okay, so the 10th term right? 10th term will give us negative 2048, and it's going to keep going up. Now, let's write an equation for this sequence, and this one doesn't have any negatives in it, but we have to find out what the R is, and we have to find A. So this is A1, and then for the R, we'll do the second one divided by the first one. So 2.4 divided by 12 comes to 0.2. Then we do the third one and divide it by the second one, and that's also 0.2. So that confirms we'll accept that R is equal to 0.2. And now let's make the equation. The amount at the nth term, or at an nth term, is equal to the amount of the first term times the ratio and times n minus 1. So we have two things to put in there, the 12 and the 0.2. The AN is equal to 12, 0.2, n minus 1. Now, that's the equation. There isn't anything to do. We cannot multiply 12 and 0.2 because the exponent is required to do that first. You do this part first. So exponent before multiply. Now, let's figure this out for, say, 6 years, or 6. N is equal to 6. That means the amount at the 6th position is 12, 0.2, and 6 minus 1, which is 5. 0.2 to the 5th power, let the calculator do that, multiplied by 12, and we get that a to the 6th is equal to 0.00384. So notice, because this is going down, that was the third one, and then there's a fourth, a fifth, and a sixth, and the sixth one, 0.00384. So I'll do that just for the fun of it. But this one in particular asked for the equation, so good. Okay, so hopefully that helps in figuring out the equation and then using the equation for these types of problems. Okay, thank you for listening and watching.